Manufacturing has always been at the core of motorsports. At one point in time, it was more on the racer than it was on the vendor, and that's flipped over time, and it's beginning to flip back the other way. As you look at the motorsports landscape now today, and Team Penske is a perfect example of this, we've went to buying at least 50% of our parts from vendors to now building the majority of all the parts to go on our race car. Now, we can't build the tires, and we have different partners that we work with on various parts, but a lot of the parts on our race car today, we build ourselves. Parts I'd never thought we'd ever build ourselves. We're building ourselves. And that's because of relationships that we have in manufacturing, like this one with Mazak, to where we're at now today, because quite simply, Team Penske, through the Mazak relationship, builds the majority of their own parts for the race car, and I can't win without that. And that's a critical thing for me to acknowledge. It's critical to our success. So some of you might have been here, I think about 2 years ago. I gave the grand opening speech, the breakfast. And one of the things I talked about with Dave Despain was what makes all of us common in the motorsports industry, specifically to racers. And there were really 5 points I covered. And manufacturing is certainly one of them. But the 5 points were this. Every racer is part of a human performance element, from the basics of eating right, diet, exercise, staying in shape, being skilled with hand-eye coordination, and so forth. Every racer is a part of the manufacturing race, because if you don't have a race car, you can't race. It's pretty simple. Somebody's got to build it somewhere. Whether you bought it or you're building it yourself, you're a part of the manufacturing race somewhere along the lines. And of course, there's engineering involved in everything we do, because quite simply, if you looked at a car, the car has existed in some shape or form for over 100 years. But if we tried to take a car from 100 years ago and put it on a racetrack today, we'd get laughed out of the racetrack, because engineering has advanced the race cars. So every racer, in some shape or form, is part of an engineering element. The fourth one is we're all involved in logistics. So whether it's from driving here today, driving to the racetrack, driving to get your sources or materials to build your car parts, you're a part of logistics in some shape or form. And then as we move forward, and this is one that I like to hit really hard, because it's part of the reason why I'm here and part of the reason why this show exists. Every one of us is a lobbyist for motorsports. We tell our friends, we tell our family, we love the sport to death. It's part of who we are. And sharing that message is critical for the success and the future of this sport. And it's one that I take very seriously, and it's part of the reason why I'm here today. So I'm very passionate about manufacturing for those 2 reasons. And probably the third, but certainly not the last, but one that I really want to emphasize, is I really believe in manufacturing. I believe in it not just because it's where I grew up in. I believe in it not just because it benefits me as a race car driver, but I believe in it because of our country. I believe we live in a great country that has afforded us a lot of privileges. Let's face it, we're all racers in some shape or form. And I believe at the core of how fortunate we are to be here, to get to do the things we get to do, to be a part of motorsports, is manufacturing. You know, this country was built by a number of industrials, a number of people who are very passionate about manufacturing, and it's helped it to advance to where it's at. It's helped enable the system that we have that has permitted us to live a lifestyle of so much privilege. So I believe that even though I'm from Detroit and I've seen the machine shop struggle, I've seen all those things go down the line, I still believe that manufacturing is super important to our society, and I want to be a part of that. So I have a few stories I'm going to share with you today of why manufacturing isn't just, words, it's in action. So I want to share one story with you today. I'm very fortunate to have won a NASCAR Cup Series Championship 2012. And one of the key moments was a race that actually we didn't win, probably should have, but we finished second at. It was at Texas Motor Speedway. And our success that day was, about all those elements we talked about that make up a team, from the human performance side, the logistics side, the car side. But the manufacturing side on that particular day played a key role in our performance. So to get the gist of how manufacturing, and specific to companies like Mazak, fit into Team Penske's portfolio, here's the example I want to give. So we're at that racetrack. We're leading the points, 3 races left to go in the championship. And we've got a really fast car. And we're practicing. Things are going really well. And the weather conditions changed just so slightly. It got a little bit hotter. And those of you that race week to week know what that means. The track slows down. It gets a little hotter. It gets a little slicker. The car is going about 200 mile an hour around Texas Motor Speedway. And now it's only going about 195. Well, if anyone's ever rode in a car, the difference between 195 to 200 mile an hour doesn't feel like a whole lot, but it actually is a good amount. And it changes the loads in the car, changes how it handles. The car slides around a little bit more. These are big differences. And so as we're finishing up the practice session, the last practice session before the race, about 16 hours roughly before the car has to be ready to go for the race, we can see that the car isn't set up right. It's not set up properly. At the time, there was a rules package in NASCAR that allowed the rear end of the car to move forward and aft. And as the rear end of the car moved forward and aft, what would happen is the car would gain a rear side force, which quite simply is an aerodynamic effect to give it more grip. And so as that was happening, the loads had changed and the car wasn't moving properly. In fact, it wasn't moving enough. We didn't want the car to move too much. We didn't want it to move too little. It had to move a very specific amount. And so our engineering team went through and said, all right, what are we going to do about this? And what it came down to is there was a simple mount on the car that held the rear suspension together. And that mount needed a simple change of about 1 degree. Well, we're at the racetrack. We don't have a machine shop at the racetrack. How are we going to do this? So the guys, the team of engineers, called up our designers in Mooresville, North Carolina. And keep in mind, this is from Dallas-Fort Worth, Texas, at about 2 o'clock on a Tuesday or on a Saturday before we got on the racetrack for the race, which would have been Sunday. I said, guys, we need your help. So the design team drew up a new bracket, ran it through all of our computer simulation to make sure it would work. Then we called up one of our best machinists who was at home and said, hey, we need a part. And when do we need it? We need it right now. The car has to be ready to go in Texas in about 14 hours. Okay? So the machinist comes in on a Saturday night, works a night shift, loads a big block of aluminum into one of our Mazak machines, and voila, we have a bracket. Well, that's great. We have a bracket sitting in North Carolina that fixes our problem. So now we've got to get that bracket from the design team to the machine shop to the racetrack and on the car. So luckily for us, the pit crew flies in race morning. Someone stopped by, grabbed the part, got it on the airplane, got it to the racetrack in time for the mechanic to bolt it on the car right before tech to make it onto the racetrack. And of course, I went out in the race, and that part made a big difference in our performance. It held the rear end of the car where it needed to be, and just like that, we had won the manufacturing race. That's what motorsports really is. Every week you're racing in all of those categories, whether it's human performance, logistics, manufacturing, engineering, you're racing in those every week. And it's easy to lose sight of that. I know because as a race car driver, sometimes I get super focused on my part. And my part's important. I like to tell people that I get about 90% of the credit, but really do about 10% of the work. And I think most race car drivers are sometimes that way, unless you're working on your own car in your own shop. But it's really, really important for us, for manufacturing, because manufacturing gives us the speed in the car. And I'm a big believer that to win a race on a racetrack, you have to have the right combination of skill, luck, execution. And the skill comes from the ability to develop, design, put all those parts on the car with a race car driver that knows what he's doing, with a pit crew that can do a fantastic job bolting it all together. These are no coincidences. And manufacturing for us is what enables it. NASCAR introduced what we call the COT car, or someone might know it as the Generation 6 car, about a decade ago. And when that car came in, it a little bit shocked the NASCAR racing world. So this is my second example. And it shocked the NASCAR racing world for a number of reasons. One, because it's not a great race car. And so to try to make that race car go around a mile-and-a-half racetrack is a big, big challenge for us. It's heavy. It wears the tires dramatically. It doesn't have a lot of offset in it, so it's not made to go around left-hand turns very well. And the aerodynamics on it, it's a bit like a brick. It's nowhere near what the car before it was. So that posed huge challenges for all the race teams. And the way to solve the equation was to make the race car lighter. That was the only thing we could do to make it better. So over the past decade, all of the teams, the major teams in NASCAR, have invested a lot of money in manufacturing. So why would they do that? Well, the reason is because to ask the vendors that we have to build what we need is really tough. There's a lot of IP, which is really secret. It's a code word for secret stuff, basically, intellectual property, that goes behind what the race teams design to try to make it around this car. So what's happened is we've designed more parts now and manufacture more parts now than ever before. And I gave you the example of the brackets on the race car. That's one example. But there's hundreds of other parts. I would have never guessed 10 years ago that almost every race team in NASCAR right now builds their own seats. That doesn't make any sense. But it does now, because we can build a seat that's lighter and stronger with the manufacturing technology we have now. Even down to the pedal sets in the cars. Those are all made by the team specific. And they're made out of alloys that I can't even pronounce because they're lighter and stronger. Out of blocks of material that are very expensive. And this is no coincidence. That car coming in changed the sport. It changed all of the race teams dramatically, how they operate. All of the highest tier teams right now have their own manufacturing facilities. And they're not small-scale manufacturing facilities. They're large-scale manufacturing facilities. I think we're going to see manufacturing continue to explode. I think we're going to continue to see the vendors have a hard time keeping up with it. The vendors that are smart enough to invest in it are going to be successful. The ones that aren't are going to stay stagnant, and they're going to be in trouble over the next decade. I think that's probably one of the most critical takeaways. So, as you might notice, there's this big Mazak banner behind me. Of course, Mazak is a partner with Team Penske. Why is Mazak a partner with Team Penske? Well, Penske, which is short for Mr. Roger Penske, as some of you might know, or I think a lot of you probably know here in this landscape, is one of the smartest businessmen I've ever seen. And he makes it a point to align with blue chip brands. So what does that mean? It means he looks for the best guys and the best suppliers, the best people to work. And we believe Mazak is the best machining company out there. The reasons for that are really simple. They have the ability to create a very high precision product, and they have service that sets them apart. So what does that mean for us? Well, it's really simple. And in fact, I had this quick conversation over here with Dan a few minutes ago. We design around the capabilities of our machines. And so what does that mean? It's just really easy to say. Well, if you took Henry Ford in the first car and said, well, why did he build things this way? Well, he didn't have the machines we have today. He didn't have the technology we have to produce anything better. Sure, he learned a lot in design as he went, but as much as the design is important, which it is, the machines to produce them are critically important because it opens up design elements. And so what that means for us is by having what we think are the best machines, we can design what we think are the best parts with the most relevant technology in areas that we couldn't design before. So that might mean a part that requires a tolerance of less than 10,000th of an inch that we might have before looked at and said, you know what? We can't improve this part. We can work on it. But, you know, if we go to mess with this part, we might not get it right. Our machines might not have the tolerance, and it could fail on the racetrack. The only thing worse than being slow on the racetrack is being broke down on the racetrack. I will tell you that right now. With the technology that a company like Mazak brings us, we can operate in different design parameters that allow us to design a competitive edge far beyond what we could have before. And that's critical for us. That's critical for winning the manufacturing race. So those are some examples that I would give you. The Texas story is a personal favorite of mine. And I told you that story a little bit selfishly because I went on to win the championship. So it's a good story. There's a lot of other stories where we might have manufactured something and it didn't work. But that's part of it too. You know, there's a lot of working with our design team and engineers is a huge challenge. So let me tell you a little bit about the design team at Team Penske. Team Penske operates right now with almost 500 people. So think about it, that's a monster company. 500 people to build a race car. Of those, we have about 100 people dedicated to engineering and design. 100 people. So think of that. There is 100 people that never physically touch the race car. 100 people. I mean, it's hard for me to even fathom sometimes coming from where I've come from. 100 people that don't even touch the race car. Of those, there's another about 25 that do nothing but work in the machining and production side. And so what does that mean? These guys are running the machines. We run 2 shifts. We'd love to run a 3rd shift. It's just really hard to find people to work at 3 in the morning, as some of you might attest to. And that's what keeps us flowing. Tying all the elements together that I spoke about earlier is what makes a race team successful. But if there's one thing I want to stress here today, it's that the manufacturing element, and I'm going to say this again, is the hub. It's not the spoke. It's the hub of a successful race team. And I think those that embrace that not just as racers, but also as suppliers, as peripherals to the industry, those are the ones that are going to be successful.